In this video, we're going to be looking at 2D figures and the line of symmetry. We're also going to be looking at rotational symmetry, about a center of symmetry, and finally we're going to look at 3D figures and how you can have either a line or a plane of symmetry. So let's start off first with the line of symmetry and or 2D figures. Okay, so you may know that I love to have this smiley face in my videos whenever I get the chance. All right, so in this figure, we have a line of symmetry because we can actually have a line of reflection going straight through the figure, which can map one side of the figure onto the other side. So for example, if I took a line and it brought that line straight, ooh, that is a terrible straight line. Let's try that again. Straight down the middle, like this. Well, let's pretend with me for a second that that's straight down the middle. So if I took a line, then that would be the line of symmetry. And here's why. It's the line of symmetry because if I take, and I'm going to shade the face, if I take this part of the face, if this were a sheet of paper, for example, I could take the paper and I could fold it along that red line and fold it right over on top of the other side, and it would match perfectly. And so that's how we know that that red line right there is the line of symmetry or the axis of symmetry. Let's look at another shape. Okay, so it's a cartoon heart. It's not a real heart, of course. But yes, it is the same idea here. If we take a line, where would that line be? Right, if we take a line, I'm going to use red again, and we drew that line straight down the middle. There we go. Then I could take the heart, I could take this side of the heart and fold it right over to meet the other side, and it would be identical to the other side. So this is also a line of symmetry. So let's look at a figure that's probably not symmetric. Okay, so here are two pictures of two seashells, and my argument is one is symmetric and one is not. So what you want to ask yourself is, which of these figures can I draw a line straight through and it will do the same thing as our face, where we have half the face that maps on to the other face. This is a perfect reflection of this. Just like the heart, you know, the heart is a perfect reflection. The right side is perfect reflection of the left side. Which of these figures do that and which do not? All right, if you said that this shell has an axis of symmetry, you are correct. It is not, however, going straight down. If we try to get an axis of symmetry going straight down, that makes no sense because the right is not the exact same as the left. However, it does not have to be vertical. It could be horizontal or any other direction. And if we drew a line like that, and again, no ruler, so it's not perfect, but this shows us that if we map this side, we can take this side, map it onto the other side. So this side that I just shaded in red is a perfect reflection of this side. So the red line here is a line of symmetry. However, regardless of how hard we try to figure out maybe a line here or a line here, a line here, there's no way that we can take this and draw a line that makes it a perfect match on one side as it is on the other side. So this seashell here has no line of symmetry, no line or no axis of symmetry. All right. Now that we understand what the line of symmetry is, let's take a step further. Let's actually look at the rotational symmetry. All right, so on this page, we're going to focus on rotational symmetry. But before we do, since I have this picture here, I just want to take a brief moment to ask you, do you think this shape has an axis or a line of symmetry? I'm hoping that you're saying yes. Why? Because if I take a line and I put it straight down the middle here, I could take this side of the star, fold it over here, and it would be perfectly aligned. So this does actually have an axis of symmetry. But that's not why we're on this page, so let's keep going. All right, so we're here to look at rotational symmetry. And rotational symmetry is symmetry that if I take this star and I rotate the star around its own center, and I can take the star and map it right back onto its own shape, then it has rotational symmetry. So what I'm saying, I'll repeat and I'll say it in a slightly different way. So if I take the star that I have here, I turn it, and then it ends up being the exact same shape it was, then we are good to go, and there is rotational symmetry. So there's a little trick of the eye going on here. I actually have two stars, as you can see. One star over on the left, one star over on the right. I'm going to put it back. All right, so now my goal is to take the star that's on top and rotate it and see if it actually is going to end up exactly the same as the other star. So I'm going to rotate it. It may change size a bit as I'm rotating, but I'm going to try and keep it the same size. And so I'm rotating it. This is kind of pretty. And lo and behold, oh, well, I shifted. But yes, as you can see, when I rotate the star, if I'm not changing the size because I'm shaking so hard, there we go. If I'm not shaking and I'm not changing the size, I can rotate the star and it maps exactly onto its own shape. When that can happen, that means the figure has rotational symmetry. So let's look at it happen with another shape. All right, so here we have a square. And my question to you is, do you think it has rotational symmetry? Let's check. Okay, so take a look at what's happening here. I put down the square, and on top of it I put a similar square, or actually a congruent square. And every 90 degrees that this rotates, it ends up covering the square entirely. Covered, 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 covered. All right, so you get the point. Because this, as it rotates, it actually turns right back into the same shape. It does have rotational symmetry. Let's look at a shape that does not have rotational symmetry. Okay, so we're looking at the smiley face again. It's rotating around its center. And right now it's looking straight forward, but as it goes around, it's upside down until it goes a full 360. It's never the same until it makes that full turn. And for that reason, it does not have rotational symmetry. The circle, if we were to ignore the face, the circle has perfect rotational symmetry. But with the face, it does not. It's never the same until you do a full turn. So again, the face itself has no rotational symmetry. Okay, so finally we're going to look at 3D figures, and we're going to look at the difference between the plane of symmetry and the axis of symmetry. So the plane of symmetry, first of all, I'm going to draw a quick rectangular prism here. And what I want you to imagine is the rectangular prism being cut in half, which it's going to take some visual skills to get there, especially with my drawing skills, but I think we can do it. All right, so you see this square in here is signifying where it could be cut in half. So if I literally took a plane, like a really, really sharp knife of sorts, and I sliced my figure right here, and then these two sections, section one here in the front of the plane and the section on the back of the plane, behind the plane, these sections are now identical, so I slice this exactly in half. This is a plane. The blue plane is a plane of symmetry because it was able to take my shape and slice it directly in half. So think of it like the axis of symmetry in our 2D shape. The plane of symmetry is behaving in the exact same way. So as long as I'm able to slice the shape in half, that means it has a plane of symmetry. Let's look at another shape that has a plane of symmetry. Hopefully this will make it more clear. Let's stick to the same colors we started with. All right, so I'm going to attempt to draw a big ol' 3D L. I don't know if I'm being ambitious. Seems to be working out okay. Awesome. Okay, if I take this figure and I slice it here, oopsie. So I slice it here along the L shape. And so what I end up creating is two skinnier L's. Because I can do that, it's showing me that I do have a plane of symmetry here. So, and that plane would be whatever is cutting my L. And this is really, really hard to show, but hopefully you understand. So that plane is, let's make it smaller. The plane is cutting straight through that L shape and making those two skinnier L's. I hope you understand. This is really, really hard to show. So yes, there is a plane of symmetry in the shape because we are able to slice it and get two identical 3D objects. All right, axis of symmetry is a little bit easier to show. All right, so going back to my shape right here, my rectangular prism, not only does it have a plane of symmetry cutting the front from the back or the top from the bottom, not only does it have a plane of symmetry, it also has an axis of symmetry. Put that in black. If I drew a line straight down the center, I could take it and I could rotate, and I'm not going to play around with the crazy rotation animation anymore, but I could take this and I could rotate around the line. And rotating around the line, I would get the same exact shape when I rotate 90 degrees as when I rotate 180 degrees, as when I rotate 270. So this is very, very similar to what we learned about with the rotational symmetry. So now that we're taking it up to 3D, the axis of symmetry turns, or is somewhat a rotational symmetry. I'll show you another example. So we have a cone here, and if I have an axis going straight through the cone, I could rotate my cone around this axis and it would continuously be the same shape, which means that that cone also has an axis of symmetry. All right, so I know that there were some challenges in this video, but I hope it was clear.